Hello, hello. We're just going to jump right into it, as they say. I will do a little bit of waffling, but for the most part, I need to focus, get this crap done today. So, if you're watching this back, last time we left off, we were working on our azimuth knuckle. And what that is the... Oh, no. I printed the wrong part. That's the up and down motion of the antenna. So, we got that printed. Let's see if we can get that in focus. That's looking pretty cool, actually, and it's working for the most part, except I think I printed the wrong part, and I'll show you why I think that in just a second. So, if we take a look at our model here, I added this hatch, which is on the real one, and let's see. I wonder if there's any other smoking guns that we printed the wrong part. I'm gonna open it up real quick. I just assembled it off camera because I need to get moving on this, you know? Let's see. All right, so let's open it up real quick. I have this cobalt bit set obviously from Lowe's, and it comes with a ton of little bits. Honestly, it's not good. The bits are poor quality. The sizes are, they're all strange. So I have a bunch of metric hardware, and obviously there's SAE and metric hex fasteners, but for whatever reason, the cobalt one, none of the bits fit the metric hardware that I have. So I'm going to be looking for another bit set. I probably have several other bit sets, but I'm gonna have to upgrade here. Okay, so what I'm doing is I'm loosening the 3 set screws that are on the side, and then the top should just, here, let's go. So I'm loosening the set screws that are in the side here, which at some point we're going to need to reprint the pedestal anyway, because this one doesn't have the missing tooth. Okay, so with those 3 set screws removed, that thing just pulls off, and then you've got, let's go back to this one. You got the ring gear in there, and that lip underneath the ring gear prevents the spur gear from falling down. And then we've got our whole assembly going on. So that center motor is a 16 RPM 12 volt motor, and at 9 volts, which is what I'm just using to test on the bench here, it is not strong enough to move even the axis without any arms on it or anything. So I started freaking out, thinking I made a big mistake, because the spur gear, this little guy here, I can't stop that with my hands. It's crazy strong. But the azimuth axis, which should be a higher gear ratio and more torque and easier to move the parts, in actuality it's really struggling. So I took it over to the benchtop power supply and bumped it up to 12 volts, and then yeah, we got some more power out of it. But what it had me thinking about is, in the future, instead of directly driving these axes right off of the gear train itself, I might need to just copy the entire geometry of the azimuth axis with the little spur gear. I mean, that's the way it is in real life, so it makes sense that the motor wouldn't have, it would increase. I don't know what that is. Actually, I do know. We do know what that is. That is 1.75 to 0.54 is the gear ratio. So I don't know, is that a 3 to 1? Anyway, it amplifies the torque to have the little gear on the motor. So might have to do that for the elevation axis as well if it's not strong enough. But I think at 12 volts it is strong enough. And what I'm going to do at 20 volts, it's way more than strong enough. And if you remember, a DC motor, the voltage is it's a range. It's not a I mean, that's how you vary the speed. So I've successfully lost my Allen wrench. There we go. Okay, so what I'm going to try to do, I need to make sure that the inside here, when I printed this the first time, the tail end of the azimuth gear motor was contacting this flat spot inside the elevation deck knuckle. So I just need to know if I printed the right part. I'm not going to reprint it. So we'll take a measurement down to that flat spot that it was contacting. 1.79. Jeez, I can't get the calipers in there quite right. .54. So let's take a look at that. Let's make sure we're not going to be in any trouble here. So I measured from, oh, come back. .56. Okay, so I did print the right part. We can continue with this. The only thing that it won't have is it's not the knuckle that I printed won't have the hatch on top, which I thought the hatch was cool. We'll have to deal with that later. But what we really need to start doing is I need to start driving this with software today. And to get there, I think we should also... Oh shoot, my little set screws scarred up the race. I seem to have over tightened the set screws. Let's see if we can see that. I don't know if you can see that little defect right above the screw, but that's from cranking down on those last night too hard. Why did I do that? Who knows? Okay, well that can sit off to the side, but I'm thinking this is looking freaking sick. I especially love the detail up here for that bushing. I think that adds to it. In real life, there's not a lot of features in the pedestal. That is a big feature that I always look at, and I enjoy looking at it, so I'm glad we were able to capture that. Let's hop back into the model. And I think what I want to start with is these arms. So the reflector itself, I might just have to call that good because we're running out of time. But these arms, we need to change some stuff about those. They're ugly. And they don't interface with our drive, what do we call this? Elevation drive interface. So we should have a mate in here that we can suppress that's keeping it from moving. Why? There we go. So one thing that happened is I made this section of the elevation knuckle a little bit taller so that we would have a full circle for our bushings here. And as a result, these arms now look a little bit weeny. So we're gonna extend those, I think is probably step one. Crazy how I drew this. That's ridiculous. That looks pretty good. Let's see if we can bring our reference photo up here. It's not bad. You know, something I am noticing though is that the pedestal is a little stubby. But maybe I want it to be. It's not an exact copy, right? It's just a reference. Okay, so I like the distance on those arms. Let's add our interface features. So all we did was we took the face of our plug here, because if you remember, we're going to slip the yoke around this and then attach the yoke by pressing our piece. So this will be the outside. Why did I decide to do it that way? I don't know. I like overcomplicating things, apparently. And then I think I made that 0.125 deep. which if we go, that should be sufficient clearance. It might be too much clearance, to be honest. We'll find out. Yep. So we'll press this into the side and screw it in, and it'll interface with our okay, but that's only an 1/8 long. Give me a sec. So the issue is I don't want the screws to poke through at all, but if they are going to poke through, I don't want them to poke through much. So the screw that I have, the total length on it is 23, which should be perfect. That'll mean that it doesn't poke through. So I believe, if I remember correctly, the hole that we use for that is 1.5 millimeters. And this allows the plastic to deform enough for that screw to thread in. Okay, that looks pretty good. Now, let's look at our ref again. It's got these weird boxes and stuff. That's all RF equipment. We should make a couple greeblies. And then we kind of need to figure out, I guess we'll have to do the center of mass by hand. And then we got to figure out how to attach the dish to this yoke, because right now they are not attached to each other. And then we got to figure out how to actually print this. Like, there's a lot to do. I don't know why I made this a separate part. Maybe for printability. Alright, what do we want to do next? We need to make a configuration that is complete, which is this one. Yoke arm, which will wait, why isn't that part of that thing? Perfect. There's a yoke arm assembly, configuration. And for the reflector, we will delete the yoke arm. Okay. Before we screw around with the yoke arm too much more, we need to start printing the reflector, because that's going to be huge. That's going to be a really big part, and it's like the most important part, right? That's something that it's not an antenna without the reflector. You don't recognize it as such. So I think the reflector itself is probably done, but let's see. I'm printing something else right now, and I need to make sure that it's gonna finish. We're using carbon fiber PETG, and it's coming out really nice. Yeah, it looks really good. Okay, so we'll wait for that to finish, obviously, but let's talk about how we're going to connect our reflector to the yoke arm, and then how we're going to print it. So first of all, I want to tie all these struts together because I'm afraid of them breaking. And then what are we gonna do with that? We're gonna do this. How many sides did we do on the reflector? We didn't do 10, right? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that'll let us keep our faux paneling thing going on, but we can have a round feature on the outside. Yeah. Man, there's a lot more scaffolding that goes into that. We're gonna need to do that. Okay, that doesn't work quite as I expected it to. What I want to do is essentially like socket the whole antenna onto there. Boom. Just slide it on. And maybe I don't hate this actually. You think it could print at 20 degrees? Because if we could print it like this, nah, then we have all these panel lines. I don't know. Should these be separate pieces? Would it make it easier to print? Not sure. What is this? A mirror of what? What is this cut extrude? I know that I want to mirror those features. Weird. Got a little distracted there. Sorry about that. So again, if we're looking at the antenna now, it'll more or less print like that. But let's look at the ref again. It's got so many I think there's a brace at every one of these junctions, so maybe we need to draw that, and that'll help me. That's going to be a 3D sketch, which will be fun. So they let the water out into the river in the town that I'm in, and that is usually really gross because the river hasn't flowed all year, and then it just pushes all the crap down that it as it's going, it's got this huge head of nastiness that comes down. So I haven't been to go see it. Let's see what that looks like. Okay, so this is unfortunately, I think this is gonna be the best way to do this. Oh man, we're gonna have to do a bunch of sweeps. This is a part of the project where it's just, oh, maybe it's because I took some allergy medicine. Now I'm all tired. What should I listen to? What kind of music should I be listening to? So I guess I could spend some time and actually learn how to use this tool. That might be the responsible thing to do. But in alternatively, I could just wing it. Okay, how's that look? And then we take all of these, we pattern them. Times or 16 times. Let's check that out. I'm not loving that. Let's edit our sketch here. I think I know what I need to do. I think I know what I need to do. So this point needs to come up to this point. And this point needs to come up to that point. This one to that one. Why is that not letting me midpoint that? Let's start over. Okay, so we can come from this point to this point to this point, back up to this point. Let's try that. I don't want it to get too busy, you know? That could be bad for the aesthetics. Let's see what that looks like. Wait, what happened to my sketch? Okay. And then I should be able to insert reference geometry plane. Jeez, excuse me. Okay. That's the midplane there. We'll take this, we'll mirror these bodies. Is the problem that these are square and these are round? How bad is that gonna mess us up? Oh shoot, that's terrible. No, because in real life, some of it's square tubing, some of it's pipe. It looks like I'm missing something right in the middle there. But you know what? That's enough to drive the point, and I am not going to I'm not going to overdo it. I think that that looks so much better. Oh heck yeah. That's it right there. That's gorgeous. Okay, so before we do all that, I noticed that this doesn't extend enough. Okay, so a lot of these are not, these bodies are not connected, but we'll have to, at the end we're going to combine them all, and that'll be good. So if we merge the result, it just freaks out because half of the body's in, half the body's out. And we want to grab all of the bodies. This is not the right way to do things. Like if I was designing this as a product, I wouldn't do this, but this is a desk toy. So you get what you get. Okay. And then I want to combine this with this. How about everything and then take this one away and this one. Ready? Cross your fingers. Whoa. Oh, it worked. Look at that. Now the dish is one solid piece, and you know what, it looks freaking dope. I love it. But we need to move these body keeps and deletes well below that. Okay, now I think we're done with the reflector. Let's work on how we're going to interface it to the yoke arm. Man, we could almost just take we have this other boss extrude. That's not the one. That's not the one. This one. So we could just take an offset. Apparently that's not a chain. Okay, perfect. And then we can offset this 10125 to the inside. And when you're show bar. Yoke. And we come in here. That's what I'm talking about. We'll do that for, I don't know, an inch. 1.5. That looks good. Okay, there we go. So that's what that looks like. This part's not going to be fun to print. Maybe I need to cut it again. Dang, that scaffolding looks really good though. I'm pretty happy with that. Okay, but before we mess with the printing of that other part, let's see. I need to pull up another reference photo for an antenna feed. I need a picture inside the dish of the Dachron. I mean, they're basic. They're really basic. That's fine. So how are we gonna hold this on there? Just one screw? Okay, so the whole dish is gonna slide down on top of this feature, and I say we just lock it in with like another set screw type situation. And I think we were running those at 2.5 for a clearance. I really honestly think one will do it. we should dimension it at all. Okay, so that gives us centering between two of the legs, and then just an arbitrary Okay, so this actually shouldn't be a clearance hole if we're gonna do that. I think it was 1.5. Let's see. So that was 0.15. Get my screw out. I think it was 1.5 for the shaft. The head at 3.6. 4. And then the head depth. Oh, that's not that thick. In that instance, then it's just going to be the 150. And then what is that? What in the world is happening? Oh, because I made that. Blah, 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 blah. Because it's relevant to all the bodies. And we only want our dish bodies. Okay. That'll work. And then we can circular pattern that. Three times. done, right? Well, no, because 16 is not divisible by 3. But it is divisible by 4. Okay, and then like an idiot, these are all on the points instead of the flat spots. And they will be no matter what. So I say the dish itself is finished. Let's export it and try to figure out how to slice it. Okay, so that's our reflector and our quadrupod, which maybe I think the quadrupod parts are going to be easier to print if they're not attached to this. So we're screwing up. Are we screwing up? Must this revolve? Hmm. Okay. 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 All right. Okay. I think we fixed it. Okay. So there's the reflector. But we need to make some provisions for the quadrupods now. Okay. So if we can make... There's our quadrupods. That goes in just a little bit, that goes in just a little bit. So okay, now let's see if we can do a intersect. Or I have an idea. Let's just use the part itself. We will just select that one. Okay. Oh, I need a swept cut, not a swept boss. Boom. Circular profile. Selection manager. Boom. There we go. And we'll do 1.1125. All right.